Hey kiddos, so in this lesson we are going to review what y'all have learned about alpha, beta, gamma radiation. This video is being made after we've already done this in class. So for those that need to review, or if you are learning this for the first time, I'm going to try to make this really short and sweet, okay? So there's going to be three types of radiation. Let me move so y'all can see this. And those radiation types are alpha, beta, and gamma. So when we talk about nuclear reactions, they occur in the nucleus of the atom, and we call those reactions a type of decay because what you start with is going to be turning into something else, and it's going to break up into pieces. And anytime something starts out as one thing and it starts breaking off into pieces, that's a decay or a decomposition of that chemical, okay? So these types of reactions are nuclear reactions, and they happen because your nucleus is really unstable. So I'm going to post this on Canvas, but this is basically saying the nucleus of an atom is unstable, and it basically just has too much stuff in it. So it's kind of like if you overeat, you got too much in your stomach, you're not feeling so great, and sometimes something's got to come out. So in a nucleus of an atom, when it's holding too much stuff, it actually starts to release some extra stuff to try to make it stable. And that extra stuff that it releases is your alpha, beta, and gamma radiation. Okay? So let's talk about some of those properties. Let me see if I can make this a little bigger. I don't know if this helps for you to be able to see it from your screen. But the alpha particles, you've got this weird alpha, beta, gamma Greek letters to represent them. But alpha particles looks like a really funky A. Okay, let me step back so you can see it again. So it's got that really funky A. And then beta looks like a weird B. And then gamma doesn't even look like a letter at all. It looks like a little backwards R. It's kind of weird. So anyway, these types of radiations, they have different properties, all right? So I want you to think about the alphabet. Alphabet starts at A, right? Well, as far as the radiation goes, the one that starts with A is the least powerful. And they call this penetrating power because it can't get through much. So alpha radiation is really weak. It can actually be stopped with like paper. So alpha radiation, it's very weak. And we're going to talk about some properties in a second when we look at some reactions. But it says over here, as far as alpha radiation goes, it's the weakest. You can stop it with paper. Beta radiation is kind of in the middle. You can stop it with wood, or you can stop it with like something really like a thin piece of metal, but you don't need anything like really big and heavy duty. For gamma radiation, that one is pure energy, and you are going to notice that it's like X-rays, and it can't be stopped by anything except for a really thick amount of lead. So whenever you get X-rays, that's why you have to wear the lead vest, or the technician doing the X-ray is wearing that lead vest. That's because that's the only thing that can stop the radiation, okay? So alpha, beta, gamma. These types of radiation occur naturally, okay? And they're trying to make something that is a little bit more stable. So your alpha radiation in the reaction, you're going to notice that the particle is always going to be this helium with a 4 on top, that's the mass, and the bottom number is 8,2, which is the number of protons, which affects your atomic number. And you're always going to see that for the alpha radiation. Alpha radiation is also positively charged, okay? And so we're going to talk about how we can do these reactions, okay? So this is going to be posted. I'm just going to touch on it really fast. For beta radiation, okay, so this up here, the heading says beta decay, but it's beta radiation. It looks like an electron. Top number is going to be 0. The bottom number is a -1. And sometimes we did see this on a different practice sheet. Instead of writing an E, you'll see a funky B. On your test, it's going to be the letter E, okay? So that's how you know whenever it's beta radiation. And then gamma, I can't remember if the actual reactions on your test or not, but you'll be asked about properties. And it's going to look like this little funky letter. It's kind of like a backwards R, and both of the numbers are zeros, okay? So how do we approach reactions like this? If you want to see anything else, you can just scroll through this, all right? But we're going to go to the reactions on a different sheet, and it's going to refer to a parent and a daughter isotope, or we can also refer to that as a parent nuclide and a daughter nuclide. Just know the parent is what you start with, and the daughter is what's formed. It's kind of like, you know, a parent with their kids. Their kids are going to come after the parent, okay? Parent makes the kids. So in here, the reactant, what you start with, is always the parent. All right, let's look at an example. There's a whole sheet of these that we worked on in class. I'm just going to do a couple with y'all. And as we're looking at this, we start out with the given element. And then there's a dash in some number. That number is the mass. Okay, so the way we write this as a reaction, we write the element down again. Okay, so this is LR. The top number is 256 because that part is given. And then the bottom number is what we have to find out using our periodic table. So, periodic table is right here. So if I'm looking for LR, I don't know if you can see this or not. LR is right here. Okay, so do you see it right here? That is number 103. Okay, so I'm going to write 103 on the board. So 103, this goes down on the bottom. Okay, and then we set up our reaction, and because it's an alpha reaction, we know this is just one thing that we start with. We make an arrow, and then we write the alpha particle. So what is it? It's a helium. Top number is going to be a 4, bottom number is a 2, and then we're going to make some other element that we'll solve for in just a second. I promise this is easy though, I promise. So guess what? Law of conservation of matter, the top number on the left side has to equal the top number of both things on the right side. So if this arrow is kind of like where everything has to be equal on both sides, it's kind of like algebra, but a little easier. So 256 is going to equal 4 plus something. Okay, to figure that out, just go ahead and take 256 and subtract 4. And what do you get? 252. All right, then we ignore the top numbers and we just look at the bottom. So 103, that is going to equal 2 plus something. Or just do 103, subtract 2, and you get 101. And then we have to use our periodic table again to figure out what element 101 is. So we're looking, and we started with this one. We go to 101, and that is, do y'all see this? MD. So we're going to write MD down, and that's our reaction. Okay? Now, there's a couple of blanks that we have to fill in over here, and it's asking which one's the parent, which one's the daughter. So you tell me, which one's the parent? Is it what we started with or what was formed? It's what we started with. So I'm going to copy this back down right here as my first blank over here. So my parent is LR. Write the numbers in, okay, 256 and 103. And then the daughter is the one that you formed, not the alpha particle. Okay, in fact, all of these are going to have HE as the first product, the first thing that you write down after the arrow. But MD with 252 and 101 goes right here. Okay, and that's it. Let's do another example, and then let's look at the back of this and do a beta example. So I'm going to switch colors, and we're going to set this up. What's given is PA, 231 goes on top. And element PA, that is number 91. And then we're going to have our arrow, alpha particle again. It's always the same. And then we just solve, okay? 231 minus 4, that's going to be 227. You can use a calculator with this. You don't have to just do all the math in your head, okay? So 231 minus 4 is 227. And then the bottom number, 91 minus 2, 89. To figure out our element, use that bottom number, refer to that number on the periodic table, and it's element AC. Okay? That's all there is to it. We'll fill this in. The parent is the one we started with, PA, 231 and 91. I don't know why I can't write on the lines. Maybe you can do better than me with your paper. The daughter is AC, top is 227, and the bottom is 89. Okay? So hopefully this makes sense and you find that this isn't so bad. Now we're going to look at beta reactions, and I kind of already have one up here, but that's fine. We'll do another. So in a beta reaction, they're going to give you the same information and set it up the same way, except you have to use a beta particle. And a beta particle looks like an electron with a 0 and a -1. So when we solve for what this is, notice now we're going to do 6 minus a -1. That's really tricky because anything that you subtract that's a negative is really adding. So 6 minus -1 is really 6 plus 1, which is 7. So that's why this is a 7. And then the identity of that is nitrogen. And then we fill in, let me get out of the way so this will get a little darker. And then your parent and daughter, you get that the same way. So let's try the next one. Na, that's sodium. Whoops. Can't do it with that one, can I? That looked bad. And that's not what I'm trying to do. Okay. Now y'all are watching me struggle. Let me erase this. And then let's write it in. So we have Na, 24 on top. Na is atomic number 11. We have our arrow, just so you can see which part looks the same. Now my beta particle is going to be the E with a 0 and a -1. Now, I can already hear you now. Do you have to memorize that for the test? You just have to recognize it. You do not have to draw these or write these out for your test. Okay? So what do we get as our product? Well, 24 minus 0 is what? 24. And then 11 minus what is, 11 minus a -1 is 11 plus 1, which is 12. Write that 24 a little bit better. And then what is element number 12? You got to use your periodic table, look for atomic number 12, and that's magnesium, Mg. So to fill this in, the parent, there's going to be a couple of multiple choice questions asking you which one's the parent, which one's the daughter, or is this alpha or beta? Okay, so hopefully you'll find that this isn't too hard. I really hope that you guys do really good on your test because this you have less things to study. So the parent is Na, you got a 24 on top, 11 on the bottom, and the daughter is Mg with a 24 on top still, but the bottom is 12. Okay, so I have just like one more minute of the video that I can record, so let me do another one really fast this time. Next one is Au, which is gold, 201 on top, bottom number is 79. We're doing beta decay again, so we have an E and a -1. The top number that we form is going to stay at 201, because 201 minus 0, 201. And then the bottom number is 79 plus 1. Remember, it's 79 minus the -1. That's an 80. And element number 80 is mercury, which is Hg. Okay? And then you can fill in the daughter and the parent, because we're about to run out of time. All right. So I hope this helps. If you have questions, just message me, okay? Thank you.